Okay, so we're going to now learn a system that is going to be one of these time-saving things, okay? And I think that the best way to show you how Pascal's triangle works is actually pretend that you were him trying to figure out a better way to do this, okay? So I want you kind of in that mode right now where, hey, I see this is always happening, or I see this is happening, or whatever, okay? So you're going to come up with some generalizations. Now, we're going to just do some expanding. We're going to work with x plus y to the n today. Now, if you have x plus y to the 0, everyone see where I am? I'm right here. What's x plus y to the 0 equal? 1. What's x plus y to the 1 equal? X plus 1. What does x plus y squared equal? Okay, that's x plus y times x plus y, right? So x squared plus 2xy plus y squared. Okay? Has anybody seen any generalizations yet? Okay, let's do another one. X plus y cubed. Now that's the same thing as x plus y times x squared plus 2xy plus y squared, right? Because that's simply x plus y squared. So x plus y cubed is that. Now, just to save time, because this is time consuming, you have to multiply x to everybody and then y to everybody. I'm just going to give you the final answer, and that would be x cubed plus 3x squared y plus 3xy squared plus y squared. Okay. Yes. Sorry, y cubed. Okay. Next, x plus y to the fourth. That would be the same thing as x plus y times this, right? Since that's x plus y cubed, I'm going to go. So that will equal x to the 4 plus 4x cubed y plus 6x squared y squared plus 4xy cubed plus y to the 4. Okay, now I have done x plus y to the 0, to the 1, to the 2, to the 3, to the 4 with you. Can you come up with any generalizations, okay? Anything that you see is happening all the time. Okay, there's lots of them. Lots of things that are happening consistently. Yes, Jenny. Okay. So Jamie's noticing this, right? Is that what you're talking about? Okay, this one's kind of far away, but you're getting what I'm... Okay? Anything else? The coefficients are doubling? Or the second one? You're on to something. Come on, you guys. Pascal saw tons of things. You got to see a couple. Yep. See, that's excellent to see. Now, you may not know, but there's a 1 there and a 1 there. Do you see that if it's x plus y cubed, all of these will always equal 3. X plus y to the 4, all of these will always equal 4. Okay, so if you take these two and add them, you get this. You know, there's a 1 there and a 3, you get 4. Okay, that's awesome. Do you see if you take the two coefficients of the other one and you kind of bring it down, you get the next one? So can you tell me what the next line would look like then? Since this is your theorem, what would it look like? If I was doing x plus y to the 5, what would it look like? Just give me the coefficients first. Okay, how are you getting 7? Okay, now, who could give me the exponents? Yep. No, x to the 5, right? Okay. Okay, so there's something that Cody did that we didn't even acknowledge. How did he get all of those exponents in order? What are the x exponents doing? Counting down from 5. How did we know to put the 5? Because it's x to the 5th. So they're going, now there's actually a y to the 0 here. You see that? So they will count down from 5 to 0. The y's will count from 0 to 1. The coefficients are triangular. We got that. We also got the fact that all the exponents always add up to 5 if it's the 5th degree. There's one more thing that I want you to see. Just one more thing. You guys have done awesome. You got all the big ones. I want to see if there's one more thing you can see. Okay, and I'm talking about number of terms. Yes, Cam? Yes, degree plus 1 is the number of terms. Okay? So do you see how x plus y to the 0 has one term? X plus y to the 1 has two terms. See everyone with me here? 1, 2, when it's a 1. Now, we learned a ton of stuff here. All of these rules you need to know. The question that I need you to start to come up with is x plus y to the 20. Now, we didn't go through and multiply all this out and then do it again. Did it with the other class. It took us like 10 extra minutes to do this, right? Because it's a lot of work. X plus y to the 20th would take you the whole period. And you'd probably get it wrong. because you make one mistake in there. What I'm going to need from you is, in x plus y to the 20th, what is the sixth term? Okay, so there's got to be some thinking that has to go on there. Okay, so that's my goal by the end of this period, is if x plus y to the 20th, what is the fourth term? You'll be able to tell me. Okay? Or x plus y to the 6th, what would it look like expanded? So remember what I told you, what is a big thing about this course? Is efficiency. Because if I gave you guys x plus y to the 5 and I said work it out, I'm quite confident that most of you would have got it in about 15 minutes. Okay? But that's not very efficient. We just got this one together. I went slowly through it, and we did it in about 2. And there's things you need to check when you're done. Okay? Is it, the other thing we haven't even seen is if you draw a line down the middle, the coefficients are always symmetrical by the middle. Have you seen that? Someone kind of alluded to it a bit. You were doing the numbers. Well, they actually, from the inside out, they will always be symmetrical. Okay? There's a lot of things that Pascal found here that may seem like an extra thing we got to learn, but this extra thing we got to learn is like a tool, so we don't have to do this anymore. Okay? So, one thing that right away, simple question on the quiz tomorrow, x plus y to the 2. Now, I'm not going to give you x plus y to the 2. I'm going to give you x plus y to the 20th is how many terms? That's it. Look how fast. Bang. Done. Okay? If you know it. Okay? X plus y to the 2 would have how many terms? 3. X plus y to the 3 equals x plus y to the 4 is to the 20. Now, tomorrow you come in. I know you've done an awesome study sheet, but you forget it in your locker. Okay? How could you do this question so you remember? Because x plus y to the 20th, I'm just going to say, how many terms? And you're going to put an answer down. How do you know it's right? You should test it, right? X plus y to the 20th, you tested it, would take you a long time. So you know what I use? This is my, get my bearings from here. Oh, it's always one less than the degree. One more than the degree, right? So degree is 0, there's one term. Oh, 20 must be, so this gets me my bearings on a lot of things. Okay, now the sum of the exponents in x plus y to the 2 should equal. So look up here how we did sum of the exponents, right? In x plus y to the 3, what was the sum of the exponents? 3, okay? So in x plus y plus 2, it should be 2. This should be, and this is 4, in 20 should be 20. Now, we've already done the next thing, and I was very deliberate in how I wrote it down, so it looked like a triangle above. But if you look at the coefficients, this one was 1, and this one was also 1. Now, the way Pascal's triangle works is you take those two. Now, what always goes down the sides? 1s, okay? And then you get your other numbers by, you got 3, 3, 1, okay? And then 4, 6, 4, okay? So let's just do the next line just to make sure we're getting it. Okay, Jared, what's my next row going to be? Now, do you see how it's symmetrical by the middle? I use my, okay? So I'm not going and writing down all the rules for you. Can you get all the rules? Can you write them all down? Okay. So is this stuff hard? No, there's lots to know though. Yep. It would be in order. I'm going to teach you even a quicker way to do that. But the whole triangle is actually a lot faster than you think, because the 20th, that's too much. But the 7th, the triangle doesn't take that long compared to x plus y to the 7th. It is much faster. It still sucks, but it's way faster. Okay? So we'll even get to a quicker way. Now, when you look at this, let's answer some. Okay? Now, here is just an example. So for x plus y to the n, we're going to be general here. How many terms are there in x plus y to the n? N plus 1. There's always one more term than the exponent, okay? The sum of the exponents of x plus y in each term is n. The exponents of x do what term by term from n to 0? Decrease. The exponents of y do what from 0 to n? Increase. The coefficients of each arrangement form a, what type of arrangement? Triangular or symmetrical is more. Okay. Now, there's other things I want you to know too. This is considered row 1, okay? This 2, this 3, this 4, this 5, this 6, okay? You with me on that? Any generalization that you can make? X plus y to the 5 would be in which row? 6th row. Do you see? That's another thing to know. The row has how many terms? Row 4 has how many terms? 4. See, do you get that? So again, what's my bearings? X plus y to the 0 equals 1. That's row 1. Now, do you understand that I guess, could be considered memorization? But it tells me a lot of things. Number 1 would be how many terms are in that? Oh, it's always one more. Okay, what did I write that? Okay. The sum of the exponents is actually the same, because this is like x to the 0 right here. Okay. Maybe the decrease and increase doesn't help me so much, so maybe I'll do x plus 1 y to the 3. But it does help me with my row. The row number is identical to the number of terms. Do you see that? The row number is one more than the exponent. Or the exponent is one less than the row number. There's many ways that it can be phrased. Are you going to get messed up on wording? That's what you do not want on the exam. Because if you get messed up on the wording, maybe you're going to get messed up for the whole test. Okay? So, just x plus y to the 6 would be in which row? Row 7, yeah. How about x plus y to the 12? Row 13. X plus y to the n? Row n plus 1. Okay. Now here is the part that is going to make your life much easier. Do you see that arrangement is all your combinations. Okay, can anyone give me a generalization between row number, Pascal's triangle, exponents? Because this is x plus y to the 0. This is x plus y to the 1. Oops, I guess I should write an x. And this is x plus y to the 2. Now, do you see how me asking you the third term in x plus y to the 7th, isn't that unreasonable? Any generalizations you can see? In row 3 is x plus y to the 2, which goes 1 to 1. But more importantly, it goes 2c0, 2c1, 2c2. So if I ask you the second term, what would be the exponents here? What would be the exponents here on the... Well, what would be the exponent here? I'm losing some of you already. What would be the exponent here? X squared. This would be x1, y1. Okay? And you can put this in your calculator quite easy, which is 2. 2x1, y1. Okay, so now I can start asking you this one, or I can start asking you... Now, if I asked you, what is the third term in the 7th row? I want all of this. The third term in the 7th row, that's 6c2. Would you know that? How are you going to manage to remember that? The third term in the 7th row. Now, what is 6c2? It's obviously 15. What would be the exponent on it? X to the would be 5. X to the... Does anyone even know what the 7th row is? What would be the... It's x plus y to the... Aha. So what do those have to equal? 6. X4, Y2. Okay? Now, I can start asking you the 5th term in the 20th row. That'd be a good quiz question tomorrow. Do you know your stuff? Okay? Now again, this is one of those units, you either know it or you don't. How are you going to give me the 3rd term in the 20th row if you don't know how to do this? Okay? It's very much like the last exam. Okay? There's all this stuff, either you knew it or you didn't. Okay? This one, same thing. But you can see it can get pretty messy if you don't have it very well organized. Okay? And a study sheet might come in handy for that. And again, yeah, you're going to get it all straight. You're going to be all ready. You're going to get it for the exam. And then in 2 months, I'm going to ask you to do it again. And you're going to be like, holy, there's a lot of rules in there. What are you going to have to do? You're either going to have to pull out a study sheet you did already, or you're making something. Okay? Question?
So I get that you add the figures up to 6, but how do you know it's x to the 4 and y to the 2?
Well, because it is x to the 6 is where it started, correct? So this had to be x to the 6, x to the 5, x to the 4, right? And then, of course, that was y to the 0, y to the 1, y to the 2. Okay? So I did a lot right there that we can go right down to here. Now, I want you to add up. There's the plot thickens here. Add up all the numbers in the first row. What do you get? Look at the very first row. Add them up. What is it? Very first row up here. Add them up. What do you get? Good. Now the second row. What does it equal? 2. The third row. Add them all up together. 1 plus 2 plus 1, you get. Okay, in the fourth row, what do you get? Fifth row. 16. Sixth row. Okay, now, I need the nth row, please. The 20th row, the 50th row. The nth row would be? Is it 2 to the n? Is this 2 to the 6? Is this 2 to the 6? It's 2 to the... What's 32? 2 to the... It's 2 to the 5, isn't it? So in the nth row, it would be 2 to the n minus 1. How about in the n plus 1 row? It would be 2 to the... Well, I'm going to add 1. N plus 1 minus 1 is n. Now, do you also notice something about these two numbers? What does the 6 help you with? The exponent that's on here. And then it'll always go 0, 1, 2, 3. You'll always start at that exponent 0, go to that exponent exponent. You see all the things that are going on here? Okay, so how are you going to keep all that straight? Okay? So if I had to add all these up, now maybe you're like, I'll just put that on my calculator. Like, I don't even know any stupid rules. But maybe I'll ask you this one. Or I'll ask you to the 50th. Okay? I've got to get those people that are actually going to spend 30 minutes on that question, not finish their test, right? So, what would be... First of all, what row would this be in? What row would this be? Anyone know? Row 5, yes. Okay? What would be the sum of all those exponents? 2 to the... You can tell everybody's scared. 2 to the 4. So what do you notice? These two should always be the same, but one less than the row number. Some of you guys look like you're in a lot of pain right now. And I feel your pain. Sort of, because I don't have to write a test on it. You guys do. Well, I did write the test. Okay, so what row would this be, the final one down here? Everyone looking down here. What row is this? At row n plus 1. What would be the exponent? 2 to the n. See? Oh yeah, it works. How is that study sheet going to look after this, right? Okay, so anyway, x plus y to the n, what's the sum of the coefficients? 2 to the 2 to the n. Very good. Okay. Now, let's go down to just do example 1. What are the sum of the numbers in the 10th row of a Pascal's triangle? Very, very simple question, unless you don't know the stuff you need to do this. In the 10th row would be 2 to the what? 2 to the 9. Good. How about in this one, the 12th, or n plus n to the 12th? 2 to the 12. Good. Okay, which is 4,096. Okay. What about this one here? Now, there's a bit of time, if you're going to take this on, you're going to put this in your calculator, I bet you're going to waste 4 or 5 minutes on it. 15C0 plus 15C1 plus 15C2 plus 15C3. Yet this is a 1-second question. The answer would be 2 to the 15, which is 3, 2, 7, 6, 8. Now this next one would be 2 to the 6. But do you see? This is not 2 to the 6, is it? Because what's missing? A term at the end is missing. So that's all of this. That would equal 2 to the 6th. So how are we going to find out what this is? 2 to the 6 minus 6c6. Very good. 63. Okay. Let's keep on going. Now, last, was it 3 classes ago, we did do some of these. And I kind of showed you using like the old school way. But the old school way is actually Pascal's triangle. Now, what I'd like you to do, oh, sorry, we're going to go to this. Because if you look at Pascal's triangle, well, all he did was take that one, he tilted it. And you see how you put your ones? And then all you have to do is this. Oops. So there's 10 ways to get here using Pascal's triangle. Now, if you look to the side, you could also do it with the 0C0, right? But we're going to stick to this. Now, we could have done it this way, 5 factorial. Remember, there's 5 blocks, right? No matter how you do it. 1, 2, 3, 4, 5. Or maybe you want to go 1, 2, 3, 4, 5. Whatever you do, there's 5 factorial way. And there are 2, 1, 2. That would be like left downs, and then 1, 2, 3 right downs. Remember, these two will always equal this. And that'll give you 10 as well. Okay? But for this one, you can sort of use this way. And for this one, you can't use the factorial way. And it's not in the curriculum this year, but last year there was parks in the middle. There was one-way streets. Okay, there's things, there was actually maybe chunks missing in certain places. You can't use Pascal's, or sorry, you can't use the factorial notation on that one either, right? So this is as hard they're going to get, but by the time you get here, we'll be able to do it. So we're going to do this one here, and then I'm going to see you can do this one on your own, the other one. Now, there's one way you can tilt it, kind of, so the 2 dots are, so you can tilt your book. I can't really tilt my screen, and it's not going to help the projector up there anyway. But the first thing, what I do, is this is Pascal's triangle, but I kind of do it a little different than Pascal's triangle. This is how I do it. Okay, so you put ones every intersection on the 2 sides. And then all I do is go 1 plus 1 is 2. So I actually work sideways. Now, this is, if you can kind of see it, this is Pascal's triangle right here, right? Okay, and the next row, but what I do, instead of doing it Pascal's, you could do it that way for sure. Like you can do this next one, right? That would be 3, 3, 1, right? And you got it again. See, Pascal's triangle. If you look, it is nicely symmetrical. I should have done those in red. Okay, and then why don't I keep going with Pascal's triangle? In this one, I got 1 plus 2 is, or 1 plus 3, that's 4. Okay, then I got a 6 and a 4 again. Now the 1's kind of out of there now because, you know, I guess it's here if you really want it, right? But it's not getting represented anymore. You just do what you can here. Okay, now this is 5. I'll continue doing it in red. Then we've got 4 plus 6 there is 10. 6 plus 4 is 10. Okay, and then I got 15 here and 15 here. Oh no, 20, sorry, 20 here and 35 here. Okay, then when you're stuck at this point, then you do 35s across. And then you do these two, that's 70. And then 70 plus 35 is 105. That's a 70. Okay, and then 70 and 30, that's 105, right? And then 105 plus 105 is 210. Okay, now you could do this one by doing two separate, because when you have two boxes that just attach to each other, you can use the factorial method. Now let's just do this box first. How would you do this one? How many ways to get? How many blocks is it to get from, we'll do A to B. How many blocks from A to B? What do you got? 7. So that's 7 factorial over 3 factorial, 4 factorial, okay? And that gives you the answer 35. Now, let's do this one just separately. Like if it was its own box, what would that be? How many blocks to get there? Four factorial over 2 factorial, and you get the answer 6. And then all you do is you multiply these together. 35 times 6 equals 210. Okay, now example 3 you will not be able to do with factorial notation. You have to use Pascal's triangle. Now, I'm going to show you a little bit different way that I do them. I actually don't do them diagonally, but if you like that way, go for it. This way is very similar. So I put my 1s, I'm going to do it in red because it shows up better. I'm going to do my 1s across again and down. And then all I do is I work across. Okay? So that's 2. 2 and 1 is 3. 3 and 1 is 4. Now, what's going to go on that next one? You carry the 4 over there. Or you could even pretend there's like a 0 here, right? Because there's nothing there, right? But you should always just carry that 4 over. Okay, now, again, just go across. That's 3. The next one is 6, then 10, and then 14. Okay, because all I'm doing is like, so basically I'm doing my down lefts, they come together. Okay, and this would be 4, 4 and 6 is 10, 10 and 10 is 20, 20 and 14 is 34. Okay, then going across, I have 5, 5 and 10 is 15, 15 and 20 is 35, 35 and 39, 69. Then I bring my 15 down. Okay, 15 plus 35 is 50. 50 plus 69 is 119. Okay, we're doing all, okay? That's 1 to 15.